Okay. Again in that is VSWR pattern. So in that VSWR pattern, that will be, we are seeing that one. So how we get that VSWR? Define display graph. Define VSWR is there. We have to click that VSWR and we have to click that OK and we have to get this result. And here you see that is near about 5.6 gigahertz. That same values it will be between 1 to 2. And if is required that the value for every frequency for the dB and S parameter, it is given that the dB and S parameter value are showing is here. This is your frequency, this is your reflection coefficient. All that 500 values for every frequency it will be shown in here. So this is for measurement of that the S11 parameter. Now how to open that S11 parameter? Just you go to open. If you go to open, desktop is there and there will be open is there. So there will be go to process. There will be display S parameter is there. And here that will be demo.sp file is there. You have to click that demo.sp file. Your S11 parameter result are shown in here. Whatever previously I will show. Now our antenna is working for 5.6 gigahertz. So how you measure that the 5.6 gigahertz radiation pattern of 5.6? So for that you have to require to go to process, display that, again we go to simulate. We have to disable that adaptive interference, enable that the radiation pattern file. So whenever enable that the radiation pattern file is showing that will be radiation and excitation parameter. In here we have to change that the wave source to voltage source, because the input we can use as a voltage. So we are go to OK. Now here we have to delete that all previous result. We have to delete that all previous result and we have to go to start frequency to 5.6 and end frequency also 5.6. Just give that the enter, because only one frequency we are required to measure. So here it will be, again you press that OK. So here means it will be showing that, you see that will be filling matrix, solving matrix. Now is showing that pattern calculation. So you see that here the pattern is calculated. So here that same thing is there. Go to 2D pattern. So there will be something is there, E total, E theta, E phi. So E total means combinedly that electric field and magnetic field. E theta means only electric field result. E phi means only magnetic field result. So just to check that the total combined electric field and magnetic field for 0 degree and 90 degree, we are go to here we change that the polar plot and here we given that OK. So when we given that polar plot, so this is our radiation pattern. So radiation pattern, these two colors are showing, one is blue and one is red. So blue is called that copolarization and red is called that cross polarization. And the gain is near about, positive gain we are getting that will be gain is near about 3 dB or gain is near about that is 6. So and gain is near about 5 dB gain we are receive for this antenna. So this will be 2D radiation pattern. Also we are seeing that 3D radiation pattern. If we go to 3D, we go to E total. This is your 3D radiation pattern. Anywhere this will be shown that the XYZ axis. So anyone we are move that at which type of axis we are required. We are required that this type of E total value are required. We have to move that the E total. So this is that the 3D radiation pattern. So this is your radiation pattern are showing. Now another one last thing we have to show, that will be view. What is that 3D view? Now you see that in that the 3D view, that will be this total, the big one is your substrate, and in that substrate this portion are acts as an antenna. This portion is an patch and this one is your substrate. So this one is your top layer, top view. This one is that the side view. only substrate height and all these things, and this one is your bottom view or back view, from where we can see that we are apply that feeding point. So that is that the design of microstrip antenna through that the IE3D software. Now in that IE3D software, anything, that is another one thing is there. If we want to see that the current distribution file, that we can go to curve view, there will be demo is there, that is showing that your current distribution file. This is showing that the current distribution file. You see there will be some arrows and something are there. This is your current distribution file. The current, how it will be moved towards that the patch, across that the patch, how the current are flowing. So this is that the normal design about any type of microstrip antenna. You can cut that, the any type of structure, any type of, after that you can cut that slots and slits from that advanced edit and everything. Just already I show that something result in that the slides whenever I discuss, and that is that the overview of design of that the microstrip antenna. If any problem, anything with that the handling of that the antenna, you can directly contact with me. I will try to help everyone. Thank you all.